Welcome to Monochemistry. Today we're going to learn about the pH scale. It's a scale that most of you have heard of before, but we're going to learn a few other things about it today that perhaps you're not as familiar with. Now I'm going to show you a couple of things on the scale that are simply just review, and we'll go from there. Okay, so the pH scale, as indicated here, goes from 0 to 14. The middle of the scale, which is 7, is neutral. Anything below 7 is acidic, and anything above 7 is considered basic. Okay, there is also another scale called the pOH scale, and the pOH scale works in reverse of what you see. Okay, so on the pOH scale, everything on this side is basic, and everything on this side is acidic. So you can see the opposites, how they work there. Alright, let's have a look at some common things that are acids and bases, just to refamiliarize yourself with it. Okay, so on the pH scale we have several things listed. Again, notice that the middle of the scale, 7, is pure water. Now if you take a look at the colors that are associated with this scale here, you'll notice that they change from kind of a red color all the way to a dark blue. Okay, and those colors are what the pH paper, if you were to use pH paper in a lab, which is soaked in, by the way, phenolphthalein, which is universal indicator, these are the colors that it would turn. Okay, so let's just take a look here at the scale. So we've got lemons. Picture of lemons here. Lemons, believe it or not, have a pH of 2. So when you eat lemons, it's very sour. They have a pH of 2. Some of the acid in your stomach has a pH of between 1 and 2. Grapefruit juice, orange juice, soda. Soda has a pH of 3. Tomato juice, acid rain. Soft drinking water and coffee have a pH of 5. Urine is slightly acidic, and saliva are both slightly acidic. Pure water really is the only thing that is going to have an exact pH of 7, unless there is a salt that is dissolved in it that also has a pH of 7. We'll get to that a little bit later on in the course, not in this video though. Seawater is going to have a slightly higher pH. Baking soda, things like Tums would fit in here. Laundry detergent would be, and milk of magnesia, Tums would be similar to that. Laundry detergent would fit in under here. Cleaners tend to be very basic, as you can see here. And that's the scale. Alright, so you can find household items, anything that has acids in it. Vinegar, for instance, would be acidic. Anything that ends in an IC on the back of a package means that it's an acid. Anything that has alcohol in it, alcohols are also acidic. Okay, so alcohols are also acidic. Anything like that is going to be acidic. Any cleaning supplies, generally speaking, are going to be basic. Look at down here, liquid drain cleaner. Very, very basic. Drano. Okay, let's take a look at how we can calculate pH. This might be something new for you folks. Alright, so the pH equations are as follows. I'm going to go through them. So the first equation I want you to note is here. pH is equal to minus the log of the concentration, that's what those square brackets mean, of the concentration of H+. Okay? Now those of you that are familiar with the term log, a logarithmic scale, you know that where to find log on your calculator. If you don't know, I want you to take out a scientific calculator and I want you to find it. On the calculators I have in class, it's right under the second function button, is the log button. Okay? So quite literally, when you calculate this, you're going to hit not minus, not the subtract button, but the minus button. You're going to hit minus log, and then you're going to put in whatever the concentration of H+ is, and if that's not given to you, well, then you can't calculate the pH. If it's not given to you and you can find a way to calculate the pH, you'll do that. Or, sorry, the H+ concentration, then you'll do that. But you need the H+ concentration to find the pH. Now, on the other side, conversely, if I wanted to find the concentration of H+ from the pH, then I would use a different format. I would say 10 raised to the power of the negative pH. Okay, so again, look at your calculator, find the log button. Above the log button should be a 10 to the x. So if I'm trying to find the H plus concentration, I'm going to hit the second function 10 to the x button and type in, again, not subtract, but the negative, whatever the pH was. Okay, so let's try it. I want you to type in second function 10 to the x negative 4 and see what you get. You should have 0.0001 or 1.0 times 10 to the negative 4 is what you should have. Okay, so just make sure you can do that. That's the kind of calculations we're going to be doing. Don't forget, we also have the pOH, and the pOH scale works exactly the same way, except instead of the H plus concentration, we're dealing with the OH minus concentration, but the calculations are the same. Important also to note is that when you take the pH and the pOH together, they will always add up to 14. Also important to note is that in some acids, the concentration of H plus will be written instead as H3O plus, because remember, the H plus ion will combine with water because it's a polar molecule and it will stick to it. So oftentimes you'll see H3O plus, but they're interchangeable. They mean the same thing. Now for those of you that aren't familiar necessarily with a logarithmic scale, some of you will be, some of you won't be, and that's fine. A log scale is a base 10 scale. So if you type in your calculator log 1, the answer on your calculator is going to come out to be 0. You can try it. And if you type log 10, the answer on your calculator is going to come out to be 1, as you can see in this chart right here. Okay, so go ahead and try a couple of those on your calculator and just see. The key to this is, though, the most important aspect of this is that this scale doesn't go up by ones. It in fact goes up by tens. So if I'm talking about a pH of 6 versus a pH of 7, I've actually changed the pH by a magnitude of, sorry, not the pH, I've changed the concentration of H plus by a magnitude of 10. The pH has gone up by 1, but the H plus concentration has gone down by a magnitude of 10. And that's very important. Okay, so I've left this here, this little chart here. What I want you to do is I want you to use the equations that I just gave you, and I want you to complete the chart. Okay, so type in the numbers that you need to do, figure out what the numbers are equal to, and then determine what the pH is. Okay, and then do the other calculations, like for this one, for instance, right, and fill in the chart. These are the references for the pictures and also the Creative Commons license. And that in a nutshell is how pH, the pH scale works, and how to use the pH equations to calculate pHs or the concentrations of H plus and OH minus. Bring your questions to class.